Hello. So we are now going into the sign billboard generator. Okay. So right now I'll show you one of the options. Let me cycle through. Let me find one that I like the look of. DMU. Have that regenerate. And I think I'm going to be focusing more on explaining the adaptive, because this was one of the more complicated sections to make, one of the more complicated styles. So we shall start with there you go. That's a cool sign. Right now I'm display rendering a clean node, and this is removing the vertex colors. But if we look here, we can quickly see the vertex colors if we finalize. There you go. Look at the clean. So I'll keep the vertex option on for now, just so while we're cycling through. And I think these are some of the main points that I want to go over. Is one, vertex colors and why I've allocated them like this. Two, the unwrap. Three, the stance. The edges and how we get different edges depending on what option we choose. So this is like a nice trim frame, like picture frame. But when we choose adaptive or circular, it changes to an oak. Not oak, a bark. Oak is just a type of tree. Bark is all of it. Okay, there you go. So now we have the start. First node, we've promoted. I realized I didn't really go over this very much on the last one, but parameters are really important. They're really important for what makes these tools work. So I've structured this as font parameters, structure parameters, finalize, and MOS parameters. So I've put them in that order on Jesse's suggestion, and also some suggestion from other students who I've asked to try and make something. So font comes first because choosing your text, the size, the font, the tracking, and this fit shape to font that is specific to a couple of styles. So I'll go through that in a bit. These are all things that we're going to be wanting to do first, and then we move on to structure. So this is making it so when the letters are generating individually, that they've got a little bit of random transform, that the letters can lean forward. Now the reason I wanted them to lean forward is because if I look up traditional Japanese sign, we've got this one. Now this is my reference for quite a little bit of what I've made, and if I quickly try and make that again, then we can decrease the tracking, change ours to be stereo, have it just random letters. So that's what I was aiming for, to have that, and that's what it procedurally generates. And then we've got more control, so we can have these really small signs like over doors, or I don't know, on the roofs. There's a I went over this in the guide of how to use, so like sometimes you get issues with the boolean, and that can just be fixed by slightly changing some of your attributes. So now let's put it back to the Japan version, and we'll get 3 letters. That's a good number. Quick enough that it generates, but it's also got enough variation that we can actually see what's going on. So now let's go through the nodes. We start with the font. These have been exposed. If you see here, this is what it's referencing, but if we actually click on the parameter, it shows us the channel, and this is the, I presume it's Vex of referring to a parameter. So if I change this to say font, it's probably not going to work because it's there you go. So now it doesn't know what to reference because it's looking for channel fonts. So now there is no channel font, so it doesn't know what to show. If I put that back, there you go. Now it does know what to show. Same here. So text is referencing the text channel. Tracking is referencing the, oh yeah, I was already saying tracking, so tracking X, tracking Y, and then we've got font size, and that's it. So we're generating basically a really high poly plane that looks like these letters. They're curves that are then filled in. Now we have our first 4 options. So if I just bring this up, and we'll go through them one at a time. So this one, you'll notice it doesn't have a for each loop. You can probably guess it's because this is the one sign, so this is one solid sign, so it only needs to generate one thing. The for each is because we're generating basically a sign for each letter. Same with all 3 of these sections. So we'll go through the smaller one first. Now, if we had chosen this, and we had chosen the whole version, you'll see that that would fit our letters on it nicely. So the way that that works is that it gets the bounding box of our letters, and then because it's getting a bounding box for each letter, that's going to be referenced down here. But right now, we're getting all of the bounding boxes and we're combining it into one big bounding box. We then, I've added a little subdivide here, and I've removed the poly bevel. The poly bevel, it might not even work anymore. Yeah, because I've added the subdivide. So the poly bevel was to get this to have like a round edge, but I changed it because this sign was initially to be used as a neon sign in a different student scene, and then I was like, you know what, I wanna have this in my scene as well. So I changed it to, instead of being neon, it is wood. So I added this subdivide to be used later, because I needed more topology later down the graph, and adding it there caused issues. So I came back and added it here because this is where I needed it. Now that shows us whole board. So let's go on to the next one. So the next one makes squares per letter. So that's slightly different. So if I click on the any of these in the for each, it's going to show us one of these for each loops. But if I change it to single pass, I can actually scroll. I can scroll through which one I want to look at. But we don't really need that for now. But we might need it for some of the other for each loops down the line. So this switch is supposed to reference the one of the parameters here. I'm not sure why I've cut that off. It might have broken something later down the graph, so I've just got rid of it. So that is fit shape to font. And right now it's only referencing switch 2, which is, I presume, here. But what that would do is basically make a grid where the size is being controlled by the bounding data. I wonder why I broke that. Let's put it back and see if it breaks anything later down the line. So the way that you'd put it back is you drag this input and drop it in the channel section, and then you press apply. Now you can see, like, right off the bat, that's now made. Why would I turn that off? Maybe I just never connected it in the first place. Okay, let's just quickly see what that generates if we change it to be the I'm not seeing any issues. Okay, I'm gonna leave that. Yeah. Okay. So back to it. So that switch, same as this switch. See how now it's referencing CH, so channel fit font. Same here. Now this one's slightly different because now we're moving on to these ones are wooden signs with dark wood trims, like picture frames, but these ones are generating logs, so they need to go on a different part of the UV. Here we can see them on the UVs, and this is something that I'm quite proud of, which is that each one starts as the same circle, and it's just instance to each point, and that circle starts on this part of the trim. Now I've made the trim specifically so that let's quickly get it open. There you go. So specifically, we call it, I don't know really how to show it on here, but you can see how each one of these circles has got a slightly different ring, because there's 4 options, and then they get randomly rotated and they get randomly offset by 0.25 transform along. I think it's U if it's its way, I think. So yeah, which is cool. I like that. Now we have 2 options again. So we either have the one that is a full circle and one that fits to the letter, and same thing. They're using the same circle. They're unwrapped in the same way. And then we move on to the adaptive. So this is by far the most complicated one, which took the most fixing, I guess. Let me talk. I feel like I need to talk about this section and what it took from me. So basically, we are running through them, and you see here how we've got circles on the unwrap, but we have organic shapes for the actual geometry. That was like my #1 goal. My #1 goal was to get an organic shaped edge that kind of fit to the letter. Have we still got the letter on view? Let me see in the textures. Let's go to see how it's kind of made from the shape of the letter. So I wanted that while also keeping the rings consistent, which is like, of course, if you get this close, you're like, ugh, look at that UV stretching. But from like the player's view, which is going to be like down here or something, like you can just see, oh yeah, that's kind of following the edge. So I think this maybe took me 4 hours of experimentation until I found, like, not even found, I just remembered the easiest way to do this, which was make a circle with the correct UVs and then simply move it to be in there. So this this node here was my initial plan, and I'll show you why that doesn't work. So if we come to here, It's black just because of the CD values being set, the vertex colors. But you can see this is clean geometry. Everything's working fine, even though it's coming from that original, like, more organic shape. Everything's working fine. If I stay rendering that one and swap it, so instead of our output being this, I plug in this. Fuck. Okay, good. This one happened to work. However, I need to see if I can, like, force something to break. It was on the wrong method. It wouldn't have shown me. Okay, so depending on the shape, there would sometimes be instances where, and I'm not sure why it isn't doing it now. There would sometimes be instances where your lines here would so it isn't happened here, but it would end up overlapping, and then you would end up having normals facing this way, and then the extrude that is powered by those normals would end up having the faces come forward and backwards, and then everything that worked off of that shape just got broken. I think I can maybe force it to break if I type out something else, but I guess it wasn't that, like, common. Just let it recook. I probably should have turned the vertex colors off, just so this worked a little bit faster. Okay, that's interesting. Got a crash. So while that does that, let us talk a little bit about why that would have broken. So imagine you have a hexagon, and that hexagon is made out of connecting points like this, and I wanted to conform that hexagon to a different shape, which was maybe this. Now you're gonna probably get some artifacts, some things that are wrong, because you look at this shape and you look at this shape, the shape's smaller, it's rotated slightly, so you're gonna end up where basically you've got two triangles that are, like, running along each other. These are two triangles, and then rotating it slightly so that these 2 points go down here, and maybe these 2 points are supposed to be down here. Then you've ended up with some ugly overlap going on, which is basically what happened. And then imagine trying to extrude. This is fine. You extrude this, and it's supposed to go forward. It's probably, like, a really bad example. Let's do this one. There you go. Got, like, an extrude see-through wire mesh cube. But if this was made with two triangles, where one was coming outwards this way and the other was coming out the back that way, you would end up with the extrude taking that face this way and this face that way, which isn't what you want. It's not what you want. So that would break it. Don't save. Okay, so this is interesting. We've got a crash. So let's just quickly reset. It shouldn't. Oh, the crash would have been caused by the actual issue showing up. So what's probably just happened is we've forced it to make some topology that was like that example that I showed you. Let's put some ambient noise on while we wait for this to load. Some I don't know. What's this? Birds. Nice. We're getting there. Quick detour. And we're back at it. Okay, so that didn't work. We're gonna quickly DMU. Get back into our fonts. Japan version. That's gonna cook. Gonna make it 1. We're gonna make it adaptive. Give him a bit more space. Lean. Random transform. Boom, boom, boom. We've got our sign back. We're gonna keep the vertex colors off this time, just for now. And we're back at stage. Okay, I'm not going to show you that again. Trust me, it will break. So we're only here. Sorry guys. The fix I ended up doing is that we took this shape, which had bad topology but the correct UVs, and simply you can't use an attribute transfer to transfer from vertex to vertex, and the UVs are saved in the vertex attributes, so they are here, and we need these on our other original shape, which is this nice clean one with no triangles, no pre-cut triangles anyway. So that's nice and clean, and then we transfer the UVs. Now it's not perfect. You see there's a little bit of wobble. That's fine. And then we put the UVs back on the vertices, and then we've got our nice rings. Another thing I did try, I was going to show you the attribute wrangle, but apparently it's gone. Was that another issue with the circle conformer was that the way that it worked was based off of the point numbers. So I'd basically say here we've got 0, 1, 2, 3, 4 all the way around until we get to 44, and that's because this resample node I've set to specifically generate 45 points, so 0 to 44. Then I gave the circle exactly 45 divisions. So logically, it would be anywhere the point 0 just goes to point 0, point 1 just goes to point 1, and they just match. And then I was able to have I don't know if I have on this one. Yeah, I've got a blend number. Now this blend, perfect. So the point of this blend was so that I could have a smaller value like 12 and let the user, which I had to end up scrapping, because I wanted the user to be able to basically control a percentage of how much the log was like the letter, so that you could go from perfect circle to like some sort of middle value where it's like kind of circle, kind of not. And some of them it worked perfectly, but then others, our 0.5 value is like in the center of our shape, because it was just flipping the whole shape around and rotating the whole thing. You can see here. And I wasn't really sure why it was doing that. Then I thought maybe it was because of the numbers, and that if we look here, 0 is down here, but then the 0 for this is up in the top left. So then I made another attribute wrangle that took our bounding box, and it basically said, here's the bounding box of this shape. Now 0 is always in the top left for this one. For some reason, it's always in the top left. So then I got the bounding box of my circle, and then said, imagine this is a circle. And then said, get whatever point is in the most top left. So in this instance, let's say it's like 24. And then find wherever 0 is, which if 24 is here, 0 is minus 24 in this direction along the circle, and then we would have 0. And then I had an attribute wrangle that used a sort. Maybe I used attribute wrangle to make an integer for the sort to use to just move this number. So in this case, it would be 0 by this number all the way. So that 0 would now be in the top left. Really finicky way of doing it. Took me ages to figure out. Still didn't work. So then I was like, okay, so it's not about where the point is. And then I figured out this after a little bit of thinking. Yes. Okay, so we're going to ignore this section. This section was specifically for the neon. It doesn't fit to my concept, but this is where we basically take the individual letters, and I'll quickly show you what the end looks like. And then the individual letters get made into geometry, and they're very heavy, but it was intended to use with nanite. And then it quickly makes like a metal structure, so you could maybe have these like along a gap in a back alley. I saw a couple of concepts, a couple of references from the person this was intended for that kind of looked like this, so I was like, yeah, okay, that works. So let's go from here, and we're going to go straight to then processing it. So that gets plugged into this switch, and this switch is where we choose. We should name these better, but this is where we're referencing the style channel. Right now, the style is going to be set to adaptive, which we got whole, square, circle, and adaptive. So adaptive is number 3 from 0 to 3. So then that's going to show this one, and then we actually, it would be a lot more efficient for me to do this differently, but you actually generate both the bark version and the picture frame version for all of the options. And then when you get down here, you have, if the style is circle, say yes. If the style is adaptive, say yes. And then that kind of filters it to only show the correct one per style. So let's go through the bark bit, because the bark bit's important. What we do is we start by giving it some thickness. Now the thickness is instantly going to break our UVs, because now we've got this whole extra section that's automatically being put not only in the wrong place but the wrong orientation. So that's something that we need to work on later on. We then want to make sure that we fuse all of these points. Now there are just a couple extra extrudes. So the reason I made this edge is so that we had more to put on the trim sheet, because if we look at like a reference of like an oak slice log, we've got this kind of like ready edge that will always be kind of like a little bit darker from the bark. So I wanted to get that in, and we can see that's getting set up, and we've got another one. Now this is a slight dip, so you'd presume for these logs that they were cut a long time ago, and it would get to a point that the bark's going to start like coming away, and you'll have like a little gap, and depending on, so this was like really cleanly cut, but then you got here, got like a gap forming, so I wanted to get that in as well. So that's that little topology there, and I got topology to work with because these are again intended for nanite. Then we want to use a little smooth, get like a nice shape to get. Sometimes we get even sharper points than that, and then we want to get that UV sorted out. So we flattened it, but if this was bigger, which could be an issue, that this shape would end up maybe getting unwrapped wrong. I haven't seen it happen yet, but yeah, that ends up organizing. So this section makes groups. The groups were made in the poly extrudes, and then we use blast to just unwrap. So we've got that red edge, then we got the bark. Now we've got this. So we're at this stage now. But what do we need next? We need like a bumpy edge. Yeah, so that bumpy edge is done. We got a little subdivide to give us more topology to work with, and that's only been put on the bark, which can cause issues later on. I haven't seen any yet, so don't fix it if it's not broken. Then there you go, we use a mount-ins just on the edge, which then gives us really nice silhouette and breakup, and the light will catch that nicely. And we've got a little transform. So this transform is for if we are and aren't leaning, and that switch is linked to the lean channel. Then we need to go into our support network. We take in our shape, we get its specs. So we've got the bounding box and the minimum point. So these are important because we basically want to spawn the center of our stand at the minimum point, and then we want to use the size vector to control how long the stand is. Now this is another part. You'll never get a stand for the logs that's longer than this, so this doesn't need a second section. Yeah, but on other ones there's like extra stages that I had to do, so I'll show you that in a bit. But basically using textile density just sticks them down at the bottom, and because that's where the strip of metal is on my trim, it just works. They're all at the bottom there. This shape I made by hand. It generates with every for each loop. I could have done it by like specifically making this in like Max and importing it. It's just I think it's a bit cleaner if you stick in Houdini. And this is also referenced in these options if we end up making this support for style 2, which is a circle. Yeah, so also notice how if we choose style, I mean if the sign is taller than it is, the sign is taller than it is wide. Yeah, wait, I might need to draw this. So this is our sign, and it is taller than it is wide. So the support is gonna go on the side here. But if it's wider, we put the support on the bottom. Now the exception is that this is like the whole combination of letters. So if I put D, M, U, this is taller than it is wide. we're not looking at like the individual letters, it's the whole shape. And DMU is wider than it is tall, so this would get a support. This would get support on the bottom, this would get support on the side. I hope that makes sense. So yes, we've got a switch node that basically says like ignore this, we'll use a different stand if it's vertical. Then we got a little remesh. So we've clicked lean on, so it's showing the lean. We're seeing the UVs. Then what does this one do? So this is applying our vertex colors. This is using metadata. So metadata is basically what iteration, but that's what I'm using, what iteration we're on, and then we use that. So we have the iteration detail. We make a random float. We then use that random value with our step index, which we've made here, and times that by 0.25. And then when we come to the UV transform, we use that to, so in this one it's generated 0.75, and that just moves everything randomly along the U axis. So then we've got variation in the UVs, which I think is really clean. Okay, so we can stick this on in case we want to look at it without the CD values, but we'll just leave it off for now because we are focusing more on the vertex colors now. So let's get down to Boolean. So the Boolean now cuts the letter out from the front face. Now if we have, I think it's probably a good time to put vertex colors on. We're gonna let that cook. Let's just quickly go over this stage. So this takes the letters, makes them into basically stencils, like print stencils that we can then push into the tree, into the wood. We've also applied the lean value to it. Then boom, they've been removed. And this is supposed to be like pyrography. I don't know if you've seen pyrography. Is that how you spell it? Yeah, it's like this, I guess. So they've like jabbed holes into it, but mine's for the letters. These are cool. I could maybe make these if that was like something that would be faster to do procedurally. But yeah, okay. So sorry, let's get back to it. Now we've merged them back. We've got our log shape, our log's unwrapped, our stand is unwrapped, and our letter is cut out. So this is basically nearly done, but there is quite a lot still left. So because of the options that we've chose, this section isn't needed, so we can move on to this. Then at this point we've applied the random transform. We then have set material names, and then we are coming down to this bit. Now this again is a bit finicky, so using divide on some of them caused issues and on others it didn't. So basically I've set it up so the divide only works if you choose style 1 or 2, and then style 0 or 1, which is the not organically shaped signs. Then we get our I feel like I don't need this. Did that break it? Doesn't look like it. I'll put it back on. Yeah, I feel like that. But here we go. This is a visualization of the burnt attribute. I think that's what it's called. Oh, okay, I'm still using CD apparently. But basically, what we want now is to make this a vertex green. We then want moss buildup on red, and then ambient occlusion. Well, we'll do curvature with blue, and then they'll all be usable in Unreal. So the way that we're doing that is with our moss. It's called moss and lichen because I've nabbed it from my tree generator, where it does generate lichen, but we're not using that here. So we make our ambient occlusion. We stick it with an occlusion attribute. That occlusion attribute is then used. So this is cool. This is something I learned. So you can basically just make any node that you want. If you can figure out the kind of like maths of what you want to do with the attributes, you can just make your own node, and customizable node as well. So you come up here and you do edit parameter interface, and then I can drag float values, give them the right label, give them like good default numbers, and then you apply it, you come out, and then they're here for you to use. And then when you want to reference this, you write CHF because it is a channel float. If it was like a channel string, you would want to write CHS or CHI for integer. And then you just write the label, and it has to be exactly the same. So if I change this to be a capital M, it's changed the outcome. It's changed the maths because now that's just coming through as 0. So we want to take our vector. Oh yeah, I forgot about this part. So initially, this attribute wrangle used a vector, which we would set here. So that's a 3 vector, which basically tells us which direction the moss should grow in. But I know a lot of people using this tool aren't going to be able to know what 3 vector equals the angle that they want. But people do understand degrees. So, and because like I wouldn't be able to go, oh yeah, I want it to be at this exact point. That's going to be 1.5x 2 point something y. So I was like, okay, instead I'll do it in an attribute wrangle that uses maths that I thought I would never need doing a game art course. But we basically take degree inputs that the user is got in their parameters all the way back up in the Billboard interface, and this is the moss, yaw and pitch, and then we use cos and then the whatever. So if we do it here, so we've got float, yaw, which is radians, channel, float, moss angle, yaw. So that's I think that's this one, yeah. And then we've got radians, moss angle, pitch, and that's going to be here. So now this is referencing pitch, yaw, pitch, pitch, yaw. So if we quickly just look up, I think it's called a sine table, we can see here cos theta equals whatever, depending on what theta is. So right now we've got theta is 90, which means that this would output 1, and cos at 90 output 0. So right now, because we've got 90 and 90, what is happening is our direction on the x-axis is 0 times 0, which is 0. Direction on y is sine 90, so that's 1. And then we've got direction z, which is cos 90, sine 90 as well. So then that's 0 times 1, so that's 0 as well. So then our v, so this is making a vector, which we can then see up here. Here you go. So because we've got at 0.2, I think if I get rid of that, it might make nicer values to look at. Maybe not, but interesting. Very exact, I guess. So I think this creates decimals that are like so long it's easier to just round it to something like this, like √3/2. That's going to create a horrible decimal, I think. So we can also try and recreate other values. So if I change it to be which one of these are like noticeable? Let's flip it. So if we put 0 in yeah, let's put 0 for cos inputs. So we reference cos with pitch and yaw. Let's just change one to 0, and we'll see how these change. So now we've got x is odd value, the weird value. We'll ignore that one. And then we've got y is sine pitch, which is 0, and then what is that in here? Sine 0 is 0. Same thing. Cos pitch, so cos 0 is 1. So then we've got that. Times by sine 90, which is also 1. So yeah, so it's working. I'm not sure what this value means. I didn't concentrate that much in maths. Okay, so let's carry on. You now understand that we are then calling a vector. We have a float, and a float. Now these floats control the MOS intensity, the MOS noise scale, and the MOS streaky Y scale. So these are just different noises that are also being multiplied by the vector information. So then we end up with our final MOS mask, which is growing in this vector direction using these noise attributes and this intensity. And we're also using the AO value, which is being set float here. So then, yeah, we've got our occlusion value, which is also being used. And then we've got this clamp, which basically uses all of them. Which is really cool. Cool math. Then we've got secondary noise, which is just used to remove, and a third one, which is used to add to that MOS mask. Then that's what this is. So we've got MOS mask equals MOS mask minus MOS mask removal plus that's why it didn't work. Naming conventions. Silly me. Let's see how much of a difference that made. Hardly does anything anyway. Okay, let's move on. So lichen mask, we're not actually using that, so if we broke it, it wouldn't do anything, but we can add it in if we want, because we still have all the attributes that are being used, so which is here in the attribute wrangle that's responsible for displacement. So we use the float values. So right now they're coming up as red. They're actually numbers. So if we look at our CD, anywhere that's red is CD1. Anywhere that's green, CDG1, B1. So this point here is white, apparently, which I doubt from looking at that. But so then you got parts here which are black. Yeah, that's more likely. That thing was fully black. So these are referencing our channel for displacement and MOS fall off. They're the ones that we really need. So we make our floats from these channels, Then we use branch level. That's just taken from the tree. That's not going to do anything because that isn't a branch level integer. And then a fall off, that also isn't going to be needed because it's using this integer. So if I got rid of this, it wouldn't make a difference. But I'm going to leave it in there in case I'm wrong. If it isn't broken, don't fix it. And then we use moss displacement. So this float is made by using our moss mask times our moss displacement times our moss fall off, which is controlled here. So actually that might have broken it if I got rid of calling that moss fall off. And then we've got our lichen, very similar, and then our displacement is basically we take our position and we multiply it by the direction of the normal and our moss displacement and lichen displacement. You can ignore the lichen bit. So it's basically saying with these hairs, it takes the direction that the hair is going and says move along this line by whatever number this generates, which is cool. Then we've just got ambient occlusion for the AO mask, and then we have an attribute wrangle that sets R as moss mask, blue as AO, and G as burnt. Yep. And then when we leave, that means we've got something like this. So yeah, and that's going from this value because we changed the pitch. Okay, so we're not done. We still have more. So let's go through and change this so now it is tall, because this is completely different now. There's quite a lot to this tool. You need to turn the lean value off if you've got a tool generation. So again, still getting all the unwraps nice and clean. There is this line, this seam here for something, and I can't actually find any meshes with issues, so I'm just going to ignore that for now. And we can change it to be simple, and you'll see it update on the UVs. Very cool. And then look, as I bring this value up, you'll see the value here. Now let me just turn off finalize render because we don't need to see that right now. So this is my for each loop in action. If this exceeds the UV, it's going to want to put it down here, which isn't going to be in the metal strip. So you have to take it a little further. Oh, and then so now right now it is making it wood because it's gone down into that section. Yeah, and we still make it long and long, and it's in the wrong section now. So I didn't realize I left a demo in here, but let's quickly demo how to fix this. So let's find which support section is this. Okay, so here it is. Here's a for each loop. Let's see why it's not working. So it's unwrapped. How well have they unwrapped it? It hasn't. So this might be an issue with the UV flatten. Instead of using UV flatten, let's see if a labs auto UV works better. So what we want is each face to have its own section instead of it being all the way around, because that might be too big. So let's put it like here, maybe here. That's still too close. That works. And then this UV flatten works for everything else, so I'm going to keep it because again, don't fix if it isn't broken. And then we're going to set up a very quick switch which will reference our CH bracket oh, do I need to put CHF bracket There's like a special way of saying this. No. Dot support type. I'm just going to copy this one. So basically, this, even though it's a string, is an enumeration. So if you pick the first option on the list, it's going to come through as 0. Second option is 1. So right now, if we choose 0, it's going to show UV flatten. If we choose 1, it will show auto UV, and anything else I think will also come back with auto UV. Now, if we just quickly check, simple is the first option, 0. So we need to go back in and make it so that the UV flatten, see? We swap that round back, wrong one, right one, and then hopefully that's just fixed it. So the textile density, oh yeah, because this is 4 each. I was thinking that's way too short. But there you go. It's made them all the right length. Cool stuff. But now it's all showing metal. Fixed. Fixed real time. I didn't even explain how that worked. So basically, it logs every shell and basically says what group it's in by how long it is. So if it exceeds too long, it basically goes, okay, well, this is now the long group, and everything in the long group, which has been pushed down there, needs to move up by a bit. Because I manually did that, it might break if I change stuff, which just means I would have to go ahead and fix it. But for actual light generation, it's all working at the moment. And if I change now to the complex, it's gonna still be, it's gonna use the UV flatten, because that was working for this, but for that apparently. I guess it's the same on the bottom. Yeah. That's just because see, I've already, I'm guessing that the bit that's responsible for displacing long shells not displacing that one, even though it's still a word. Okay, I do know how to fix that, but I'm not going to do it right now, just to keep the video. I don't want to make it too long. So we can show the side version and the square like trim at the same time. We're gonna make this option. We're gonna do standalone. This didn't really get finalized, but it still looks okay. So we can see the trim. This trim is now got the frames, and it's also got our inner faces in that strip of lighter wood. We got the darker wood section here. You can probably see if I change it to simple, you've got the metal, still the frames. Yeah. So I'll keep it as this one. So we've gone over this. This is just basically saying, okay, it is vertical. Now make this, which is standalone, and this uses the size of the bounding box to basically make the bottom section and the top section, and then it makes a long section that it will always have this like ½ meter of leg at the bottom. And the sign will grow upwards basically. And then we've got this, which is the simple support. These, same thing, their points are controlled by the gap of the tracking on the Y, and that's so that their placement is all controlled. Then you've got, where is this one? So same thing again. These placements are based off of the tracking Y, so that they go in the center of each letter. I'm not going to deep dive. These meshes are like really simple. So, and it basically comes down to merging it if it is supposed to be this one. Okay, so let's quickly show this section. So this section's different. We have a load of inserts, so poly extrudes that make the trim shape. I basically just went insert, go in a bit, insert, go out a bit, insert, in a bit, and until I got this shape. And this front face has got a group, so I can mess with that separately. We then do a little remesh, so that inside face has a bit more going on. We do have a mountains, which is not doing much to this one, but it's just a little bit of surface variation. You can probably see on the shadows. It's not completely flat. And then this UV section, I didn't expect to get this big. It basically was like plugged straight into there, and then I ended up having to do some grouping and switching depending on if you are doing squares or whole frames. And it was a bit finicky, but it works, so it's okay. And that basically, this bit unwraps the frames, so it unwraps the horizontal and vertical bits separately so that they're straight on the UVs, because they should have one of these should be some sort of like transform somewhere. And then you've got that merging back with the front face and back face, and they're just planar unwrap, so they're like over each other, which some people might not like, but like I don't see the character being able to look at the back of it anyway, unless it's like falling on the floor, which you can do if you wanted. You just generate like one letter and have it falling off. Very art directed. Yeah, and then this is randomly moved them by giving me 0.75 again. I wonder if it's because it's more of a seed rather than an the random value. Float random val equals random int. Okay, maybe that's just a coincidence, because if we look here, okay, this should be offsetting them all randomly, but it looks like it's just offset it by 0.75. It's offset the other ones randomly, but not the front faces. I haven't put this on a group, have I? No. Okay. Maybe it's just a coincidence. There is only 4 options, and we're only working with 3 signs, so there is a likelihood that they all get the exact same random integer. Okay, so yeah, everything else is much the same. It's just like taking it out from the front face, going through the rest of the sections. So you'll also notice that leaving this, we haven't got our bottom supports, because it's basically acknowledged that we don't need it. So it's returned a null value. Now, what if we have this long ways? So this is going to give something that you probably recognize, and that is these bottom faces, these bottom supports. So that's based off my reference. Now these are different from if you choose adaptive. So adaptive only have 1, square have 3, and then circular, which are overlapping right now, have that ring one that wrap around it. Same thing, just switch node that basically says, is it a ring? Is it the perfect circle? Yes, well give it the perfect circle stand. And then you have to give them like more spacing. That's the wrong one. But I'm not mad, because it still worked anyway, which is cool. Even though the textile density of this middle bit is probably going to be wrong. Oh, my posture's insanely bad right now. Let me just check myself. Ugh. Okay. Let's go back to what we were doing. Hole. So you'll notice this is the same as the square one, but it is really long, which implies that this bottom section gets stretched when we type. I'm not going to type more again. I'm just going to make this longer. If we make it longer, there you go. It stretches. It basically has a value which goes from the origin point to basically the length, but minus a bit. And then we put the center of it exactly at the center down, depending on its bounding box. So let's quickly go into here to show you that bit. Now, I purposefully generated it this long so that we can see this UV. Same thing. So we've got our textile density, which right now is unwrapping a tiny weeny little bit down there. But if we do that single pass technique and find a big one, no, okay. This is unwrapping like a lot of little pieces as well. So basically it's taken this very long edge and it's has moved it down, but then we've got the vector bounding box size and basically said if the length exceeds 2 meters, set the primitive group to long shells, and then this UV transform references long shells and just moves them up by this exact value, and then that just fixes the issue, and then we've got nice stuff, and then look, that's in. Trying to think if this has got quite a lot of stuff going on. There is definitely like more I would probably go into. So this is for the random transform if you want it. We've got, that's not it, it doesn't get used with the whole because of course there's this, which isn't right. Then we've got, we've already said about that section being unmatched. And then this is simply how, so we've got these specs we can then reference here, the bounding box of the X direction size. So we've gone basically how wide is it? This distance is let's see what this is generated. Yeah, it worked. Wait, can I should probably make a toggle so I can actually make this just like automatically, because right now this isn't an option to have a thick sign that stands alone, because it automatically just doesn't become this section. It goes null. Yeah, but it would be cool to have that added. But yeah, it basically goes, this direction is this plus 0.2, so I can get this little bit of overlap. Then we've got this size and this size, which is the square of this face. Then we've got the same thing for, oh yeah, the center is just the center of this up a little bit. And we've got this box, so this one is the middle. I've taken away that 0.2, so this is the exact length of the sign. This one, which is 0.1. I don't know why that's, what's that referencing? Nothing, but it's green for some reason. This references the size on the y-axis. This references the specs for the bounding box to get our center point, and then that is responsible for making sure that this bit is always at the minimum, always at that height. Yeah, I wonder how these look. Yeah, if you're generating like smaller things, these still do like get made. It's just they might look funny. That doesn't even look that bad. I think I should probably put an option on saying like you can use these signs if you want. these supports. But yeah, that should be everything on how this sign tool was made. I think I've covered most of the pitfalls that I fixed. It was mainly UV stuff, issues with topology and rendering after that adaptive bit, and it does generate with n-gons, because that divide doesn't work on adaptive, but it doesn't matter because when we take it into Unreal and it triangulates fine. So I just left it. Yeah, and then I've already showed how to use this, so I'm not going to talk about that now. But cool, thank you for listening, and now I'm going to go through my tree graph in a different video. Thank you for watching.